So I'll be talking on arithmetic today, and these are the things you know actually. These are the things you know normally. So I will just be aiding your understanding. Now, the first thing we talk about in our algebra is I will talk about variables, talk about numbers. Now, this is an algebraic expression 2x. X minus 1 over 4 is another one, and so on. Now, so this is an algebraic but you can have one variable, in this case x. If you have two like this, a w and z, so these are the things you need to know. Now we can solve this, so we can collect the like terms. For example, w cube z plus 5z square minus z square plus 6. Now this z square and are the same, they have the same variable, so this can be w cube z plus 4z square, like you say, plus 6, stuff like that. And this one too, we can factorize. 4x plus 12 can be 4 into x plus 3. So if you multiply it back, you get that. The same way goes for this factorization. So you can see the same thing is done here. So that means 7x over 2 is same as this and this. Now let me just focus. We have a linear equation of one variable. When we have linear equation of one variable, that means we have x. 3x, it can be y, but this x is unknown, so it's a variable. So we have 3x. Here we have 2, x and y. So we have linear equation with two variables. Then here we have quadratic equation. This one we have to the power of 1. But when we are having power of 2, we are talking about quadratic equation. When you have power of 3, we're talking about polynomial. So, but this one is quadratic equation. So that's x squared plus 6y. So that's the meaning. Now, so this first part is actually to introduce you to algebraic expression. Tell you the method of expression, one variable linear equation, two variable linear equation, quadratic equation. So that's the purpose of this first part. Now let me do this. Here, these are the, you have to know this. You've been taught this when we were in secondary school. A plus b whole square equals to a square plus 2ab plus b square. Same here, a minus b cube is equal to a cube minus 3a square b plus 3ab square minus b cube. And the last one, a square minus b square equals to a plus b, bracket close, open bracket, a minus b. Now, this you have to know it because you'll be using it a lot when you're solving equation. Now, sometimes they might not write a and b, it can be x and y. But at least by the time you have this format in your brain, you should be able to use anywhere. X, can be y, stuff like that. We decided to use a and b here. So these are the basic things you have to know. Or if you don't want to cram it, you can solve it. But if you solve it, you get the same answer. Now, rules of exponential. The earlier class we talked about exponential. Exponential means raised to the power something. So x minus a equals to 1 over x raised to the power a, right? Example of this is 4 minus 3. 4 raised to the power minus 3 will be equals to 1 over 4 raised to the power 3, 1 over 64. Same for this and same for that. You understand? So you have to know it. Another rule is this is more like indices, or more like, yeah. So we've been taught this to when we were in secondary school. So a cube plus x square, x raised to the power a and x raised to the power b equals to x. Since we are having multiplication and we have the same base, because this x is base, this is exponential. So you add the exponential. So have the single base a plus b. So you can use that. See, 3 square minus 3 raised to the power 4. 3 raised to the power 2 plus 4. So that's this. You have to get familiar with this expression. Here to x raised to the power a over x raised to the power b equals to a. X A minus B. When we have division, we have minus. When we have multiplication, we have plus. Now look at this. If I multiply negative by this, so that means 1 over, if I multiply this raised to the power by negative, that's minus A plus B. So that's what we have here. So that will be 1 over x b minus A. You get it? So it's just a way of changing the sign back here. So please follow this example. You already have the book, then you just need to adapt to it. Then x raised to the power 0 is 1. You have to know that. I think I've mentioned that anything raised to the power 0 is 1, except for 0 raised to the power 0, which is not defined. Right? So here, when we have the same exponential, we have different base. So that will be x multiplied by y raised to the power a. They both have the power of a. Like that will be 6 raised to the power 3. Please but we have to be very careful. This and this, don't mix it up. 2 and 5, you have to know the difference. Same here too. X over y raised to the power a equals to x raised to the power a over y raised to the power a. This is an example. Here when you have x raised to the power a or multiply or raised to the power b, you must multiply the exponential as ab, x raised to the power ab, like we have here. These are the rules you need to know. These are things that you should not fall for. The rules above identified that are used to simplify expression. Sometimes algebraic expressions look like they can be simplified in similar way, but in fact they cannot. Here are several pairs of expressions that are commonly mistaken to be identity. So don't make mistake. These are the things that will not work. Don't fall for this trap, so you can learn it. Let me talk about solving linear equation. Now, linear equation, like I talked about, linear equation is an equation that has all the variables. They have the power raised to power 1, like what I talked about earlier. This is a linear equation. So this is a single variable, this is a double variable. So now we are supposed to solve question related to that. This is a linear equation. X plus 1 equals to, that's a linear equation. 2x plus 2. So please, so they mention a lot of stuff here, and when you read it, you will get to understand it. Well, when the two equations that have the same solution are called equivalent equation, like this and this. They are equivalent because by the time you divide through by 2, you get this value. Now, this is very sensitive thing that I need to talk about. The following rules are important for producing equivalent equation. When the same constant is added to or subtracted from both sides of an equation, the equality preserved and new equation is equivalent to the original equation. What we are saying that anything that happens to this side must happen to the other side. Like anything that happens to any of these identities. For example, if I try to multiply everything by 3, now that will be 3x plus 3 equals to 6. So it must happen to everything. So that means this equation is still preserved. If I need to deduct, I have to deduct from both sides. If I need to add, I need to add from both sides. I need to multiply for every identity here. If I need to divide, I'll do the same for all of them too. So that's what this one is saying. And when both sides of the equation are multiplied or divided by the same non-zero constant, the quantity is preserved and the new equation is equivalent to the original equation. Now, the same thing. So anything that happens to any of these variables, this is an equation. For example, now the difference between this and this is because this is multiplied by 2. So and it's still the same. So that's what they're trying to tell you here. So linear equation involve involving one or more variables in which each term in the equation is either a constant or a variable. Now let me just go deep into this. If you have for one variable like 2x plus 1 equals 7x, you can collect the like times. 7x will go to this space, that will be minus 7x plus 2x. This one will go to the other side. Solve your equation. Yeah, this is when we have three variables, x, y, and z. It's a also linear equation, but we have three variables. But this we have two variables. Now, what are we talking about? But x plus y square is 0. This is not a linear equation because we have a power of 2 instead of 1. Then look at this one too. X multiplied by z equals to 3. It's not an equation because we don't have any sign of there should be a sign of addition or subtraction. So now I want to talk about a linear equation of one variable. It's simple. It's an equation. You just rearrange it and you get your final answer. This is what you know already. Collect the like times, add 4 to both sides. Like I told you the other time, that you get your answer. It's not as difficult as it seems. Now, the one I want to talk about is that one of two variables, which is very important. Now, let's say, okay. When we have this is an equation, this is another equation. So we call it simultaneous equation. So there are two ways of solving this question. Now, the first way of doing that is this. You can use substitution method or you use elimination method. Substitution method is when, for example, now this equation 1, equation 2. If we decide to use this equation 2 and reserve x here, then every other value goes to the other side, that would be 2 minus 2y, right? X equals to 2 minus 2y. So that means x equals to, then you now substitute the value of x in the other equation in here. So by the time you put that means we have a single equation now. Then you can have the value of your y. When you get the value of your y, then you now substitute in any of the equations to get the value of the x. Now this is what they did here. They make sure that this is taken. They converted this. This is what you know already, simultaneous equation. So when you arrange it such a way that x equals to a particular variable, then you put it back here, you see, when they solve it, they add the value of your y to be minus 1. So the same thing. So when they add minus 1, so when they put minus 1 in any of the equations, let's say for this, in the second equation, which is here, and we have x plus 2 into minus 1, then they solve, they add the answer to be 4. That's substitution method. Elimination method. Now, elimination method is quite different and easier. Now, for example, if I want to do elimination, I may make sure that one of the variable they look alike. For example, here we have, okay, for example, this is x, this is 4x. I want to make sure that this equation looks like this. So that means I will multiply throughout with 4. Multiply equation 2, this equation 2 by 4. When you do that, we have this. So you multiply by the coefficient of x. Multiply the equation 2 by the coefficient of x. So when you do that, you have this. So when you now subtract from each other, so 4x minus 4x is 0. 3x minus 8 and y, that will be minus 5y equals to. So you subtract it, you draw a line like this, so you put a negative sign here. So when you do that, this is 13 minus 8, you have 5, so that will be y equals to minus 1 that we got there. So just elimination method. So that way, so you just draw a straight line, you put a negative sign here, then you deduct it, you get your answer. So when you get your answer, then you can substitute the value of y in any of these equations, you get your x value, just like we did the other time. So that's what I want to talk about. This is what I want to talk about for this video. What we did here, you are familiar with everything, and don't expect me to be teaching you simultaneous equation at this level. Okay, but I believe, let's just do it. So and mind me, another thing came to my head now. You can also do it this way. Instead of having 4, you can divide through by 4, equation 1 by 4. So that means that would be x plus 3 over 4. That would be difficult, but it's better you do it this way, the way I did it. That makes sense. Thank you.